Article Linear Programming Problems LPP. Proof. Linear programming is a technique for determining an optimum schedule of the interdependent activities in a view of the available resources. Programming is just another word for the planning, and it refers to the process of determining the particular plan of action from the amongst the several of the alternatives. The word linear stands for the indicating that the all relationship involved in a particular problem are linear. In other words, Luma LP is only one aspect of what has been called as the system of approach to the management, wherein all the programs are designed and evaluated in the terms of their ultimate effects in the realization of the business objective. A general linear programming problems can be stated as follows. Given a set of the m linear inequalities or equations in n variables, we wish to find non-negative value of these variables which will satisfy the inequalities or the equations and maximize or minimize linear function of the variables. The inequalities or equations are called the constraints, and the function of the maximized or minimized is called a objective function, which can be maximization type of or of minimization type. The general form of the linear programming problem is maximize or minimize z equals to c1x1 plus c2x2 plus so on plus cnxn, subject to a11x1 plus a12x2 plus so on plus a1nxn less than equal to or greater than equal to b1, a21x1 plus a22x2 plus so on plus a2nxn less than equal to greater than equal to b2, so on am1x1 plus am2x2 plus so on amnxn less than equal to greater than equal to bm, and x1 x2 and x3 and so on xn greater than equal to 0, where first x1 and x2 and so on xn are the variable whose values we wish to determine and are called the decision variables. Second, the linear function z, which is to be maximized or minimized, is called the objective function. Third, the inequalities or inequations in equation 2 are called the constraints. Fourth, the set of the inequalities in third is known as the set of the non-negativity restrictions. Fifth, bi I equals to 1, 2 and so on m represents the requirement or availability of the ith constraints, and the column matrix b equals to b1, b2 and so on bm is called the requirement vector. Sixth, Cj j equals to 1, 2 and so on, and represents the profit or the cost to the objective functions of the jth variable xj and the row matrix C equals to C1, C2 and so on, Cn called the profit cost matrix vector. 7. The coefficients a, I, j, I equals to 1, 2 and so on, m and j equals to 1, 2 and so on, n are known as the technological or substitutional coefficients. 8th, the expression less than equal to, less than equal to, greater than equal to means that one and only one of the sign less than equal to, greater than equal to holds for the particular constraints, but the sign may vary from constraint to constraint.